Hello students, welcome back to your online video classes. So today we will start our new chapter, that is work, energy and power. So we will discuss these terms in detail one by one. So first of all, work. For performing any kind of work in which there is displacement, that is movement from one place to another place, we require a force. So work done is basically force and the multiplication, that is the product of force and displacement. Displacement should be in the direction of force, either in the same direction or in the opposite direction of force. A displacement which is perpendicular to the force do not contribute to the work done. If a person is using their muscles but there is no displacement, then the work done will be zero. So for doing a physical mathematical work, you have to move from one place to another place, and that the shortest distance between the 2 points will be the displacement, and the product of force and displacement will be the work done. So we will take the component of displacement in the direction of force or either the component of force in the direction of displacement. So these kinds of components which are parallel will use the cos theta terms of trigonometry. So the formula of work done will be Fs cos theta, in which F denotes to the force, S denotes to the displacement, and cos theta is the angle between F and S. If theta is 0 degree, then the force and displacement are parallel to each other, then work done will be Fs. And if theta is 180 degree, then cos theta is -1. Then the force and displacement are in opposite direction, then work done is -Fs. So then the unit of work done, the unit of force as you know is the Newton in SI terms, and of displacement, that is the length. So the unit of length will be in meter, and this term, that is Newton meter, is denoted by a term that is joule. So the unit of work done will be joule. A smaller unit, that is the ERG, is the smaller unit of joule, in which the Newton will be denoted in the terms of dyne and meter will be in terms of centimeter. So in 1 Newton there is 10 to the power 5 dyne, and in 1 meter there is 100 centimeter. 1 joule is equal to 10 to the power 7 ERG. This is the smaller unit of work done. So a person standing with and carrying the very high weight will tired because he is doing the labor, but there will be no work done as there is no displacement. Like that, when we are moving upstairs or downstairs, we are moving, but at the time of contact there is no displacement, and when there is displacement then there is no force. So as timing is disturbed, then there will be no work done. Unit of work done, as I have told you, will be the joule, or you can say that it is Newton meter. So these were the components of the work done. There can be work done against the gravitational forces, that if you are lifting something from the table in your hands, then you are doing the work against the gravity, and that kind of displacement, that is the displacement in terms of height, will be there. So the work done will be mgh. An example regarding this is given in your book, that is on page number 148, example 1. During a tour you put a bag of 12 kg from ground to your back at 1.5 meter height. Calculate the work done assuming that g is equal to 10 meter per second square. So mass is given in this question, and the height, that is the displacement from the lowermost part, that is 1.5 meter is given. Then the work done will be the force and displacement. So force will be the mg, due to the gravity the weight will be mg, and the displacement will be the height to which it is lifted. Then the work done will be 180 joule. The second example regarding the work done is given on page number 149, that is a person is pulling an object with a rope and exerting 5 Newton force such that the rope is making an angle 30 degree from the horizontal. Calculate the work done in displacing this object to 20 meter. So in this case force is given, that is 5 Newton, and the angle between the force and displacement is given, that is 30 degree. So if a displacement is in this direction, then force is applied at a 30 degree angle. So the component of force which is parallel to the displacement or the component of displacement which is parallel to the force will be the cos theta terms, and the value of cos 30 degree is root 3 by 2 as given in your question. This value is also given in your question, that is cos 30 degree is equal to root 3 by 2. So, by that calculating these terms and multiplying them, work done will be 86.6 joule. So, these were the examples related to the work done. And if the cos theta, that is if theta will be 90 degree, that means the force and displacement are perpendicular to each other, then theta will be 90 degree and cos theta will be 0 as there is no component of force or either displacement in the parallel direction, as the everything, that is the whole force is perpendicular to the displacement. The example of this kind of work done is the uniform circular motion. In the circular motion, the force is towards the center, that is the centripetal force, and the displacement is tangential. So, during a circulatory motion like this, in which the direction of force is towards the center and displacement is tangential, so the angle between the force and displacement is 90 degree, and due to that angle the work done will be 0. So, this was about the work done, in which conditions it will be 0 or in maximum. It will be maximum at the angle 0 degree and minimum at the angle 180 degree, that means it will be in minus terms. So, work done as it is in minus terms, but it does not denote that it is a vector quantity. Work done is a scalar quantity. So, the second term of our chapter, that is energy. The energy which we need for doing the work, as an engine requires energy in the form of fuel, and our human body get this energy from the food and nutrients. The unit of energy will be same as that of work, as for doing the work we need energy. So, they are the similar terms and the unit of energy will be joule. There are many types of energy. So, for doing a work, if a person is having the capacity for doing the work, then he or she might have that much energy for doing that work. This is what energy means. So, first of all, types of energy. The first term is mechanical energy. Mechanical energy of an object is due to its motion, its configuration, its position. So, these kinds of energy due to motion, position and configuration is mechanical energy. It is of two types. First one is the kinetic energy. Kinetic energy is due to the motion, and then second one, that is the potential energy, is due to the position or configuration of a body in which the energy is stored in it due to its position. This was about the mechanical energy. Then comes the heat energy, the heat which is generated in the atoms or ions due to the movement or either collision, and this heat will travel from high temperature to the low temperature. It is present, that is heat energy is present in all the states of matter, that is in the gaseous, liquid and solid state. Then comes chemical energy, the energy which we derive from the chemical reactions. Like in LPG, there is the chemicals which are present which we use. We use that kind of energy for cooking our food. Like that, except LPG, there is coal and food or battery. In battery, there is chemical energy which is converted into electrical energy. So, you can say that energy can transform from one form to another form. So, heat energy can be transformed in the electrical energy as it does in the batteries, or it can be transferred into a mechanical work, or mechanical energy can also be transferred in the form of electrical energy, as we have discussed in the previous chapter, that is generator, which actually converts the mechanical energy in the form of electrical energy. Then comes the electrical energy. We have discussed the whole chapter regarding this, that is electric current, in which there is energy in the motion of electrons. Then the next one is gravitational energy, which mainly plays its role in the potential energy. The gravitational energy is actually the attraction which the earth exerts on a body. Due to that, the energy which is generated, that is mainly potential energy, is gravitational energy. After that, a very common energy, you might have heard about it, that is nuclear energy. The energy which is released during the nuclear reactions like fission or fusions, which is used in the laboratories for various studies. It is a high amount of energy generated by a very small amount of substance. So this is the speciality of this kind of energy. All types of energies are mostly in two forms. First of all, kinetic energy, and the second one is potential energy. And kinetic energy and potential energy are combinedly known as the mechanical energy. So if someone is running with a speed of v, then for its motion, if we are denoting the energy term, then we will say that it is the kinetic energy. If someone is standing at an upper level, then the height at which it is standing is its position, and due to the position, the energy which we will discuss is the potential energy. Now, in the derivation of kinetic energy, for getting the relation between the work done and kinetic energy, we will use the third equation of motion. You might have studied about the equation of motion in the previous classes. There are total 3 equations of motion. The first one is v is equal to u plus at, second one is s is equals to ut plus half at square, and the third one is v square minus u square is equal to 2as. By this you will get a, that is equal to v square minus u square by 2s, and the work done where acceleration is a, so the force will be ma. So mv square minus u square by 2s, and work done is fs, so s will come towards the numerator and fs is work done, that will be equal to half mv square minus u square. If the body is initially at rest, then u will be 0, and at that time work done will be equal to the kinetic energy. And in general, the work done by all external forces is equal to the change in kinetic energy. It means that final energy is subtracting the initial kinetic energy. The examples regarding the formulas of kinetic energy was given on page number 151. First of all, example 3. An object moving with a uniform velocity and is having kinetic energy 2500 joule. If the mass of the object is 50 kg, then find the velocity of the moving object. So kinetic energy is 2500 joule and mass is 50 kg. Then by this we will get v square, that is equal to 100, and then for getting the final velocity you will have to take the under root, and the under root of 100 will be 10 meter per second. So the final energy, the kinetic energy in which the motion will be of the speed, that is 10 meter per second. Then the second question, that is example 4, is a bullet fired from a gun is having a velocity of 500 meter per second. If the mass of the bullet is 100 grams, then what will be its kinetic energy? The mass is given in the terms of grams. So you have to convert it in the SI unit, that is in the kg, dividing it by the 1000. So kinetic energy is half mv square. We have converted the mass from gram to kg and the velocity is 500. So by putting it in the formula of half mv square, you will get the answer 12500, that is 12,500 joule kinetic energy. The next question is, that is example 5. A motorcycle of mass 100 kg is running with a velocity of 20 km per hour. How much work will have to be done to increase the velocity of the motorcycle to 40 km per hour? So initial and final kinetic velocities are given, that is given in the terms of kilometer per hour. This is the higher unit and you have to convert it in the SI terms. In the SI terms there will be second in place of hour, and in place of kilometer there will be meter. So for converting kilometer you will have to multiply it with the 1000, and for converting the hour in seconds, in 1 hour there is 60 minutes and in 1 minute there is 60 seconds. So 1 hour will be equal to the 3600 seconds, and by this you will get the u and as well as v, in which v is given 40 km per hour, and converting it into the SI terms it will be 11.11 meter per second. So now the work done will be change in kinetic energy, and if you will put the values of the question, then it will be 4.63 kilojoule. So this was all about the kinetic energy. Now we will discuss the potential energy. We all have experienced that when any object is released from any height, then it will fall towards the earth. Why? Due to the gravitational attraction which earth is exerting on that particular object. So at this time the potential energy which the object gained by climbing or placing it at that height, then while decreasing the height, you are decreasing the potential energy, and this potential energy is converting in the form of kinetic energy. Like that, in the spring, if you are compressing it or elongating it, in the molecules of the spring there will be an energy stored, and that energy is also energy of configuration, and this is the potential energy stored in the spring, either in the compression or in the elongation. A bow and an arrow, when the bow is stressed, then there will be a configuration of it, and in the atoms or ions there will be an energy, and that energy is also potential energy. So now we will discuss the formulas related to the potential energy. So there are various positions and configurations which we will discuss in detail. First of all, the potential energy due to the gravitational field. So due to gravitational field, the force will be mg and the object will be at height h, so the displacement will be h. Then work done, or you can say that the potential energy for moving the object to that height will be mgh. As in that case, is in a simple pendulum, there is a mean position in which the force is 0. If we are taking the object from the mean position and placing it at the above position x, then there will be a displacement of x, and in this condition the mass of the ball which is attached to the simple pendulum is m, and the length of the thread through which it is attached is L. So by this the energy we will get is the half mg by L into x square. So in this condition K will be the mg by L, that is the force which is exerting divided to the length from which it is attached. Then K will be mg by L, and you will get the formula of potential energy which is equal to half k x square. So regarding this, like the formula of simple pendulum, there is one more object, that is spring, in which there are elastic limits, and due to this it can be compressed and elongated, and the formula of potential energy will be the same, that is half k x square. So two examples are given related to the potential energy. First of all, example 6 on page number 153, a student lifts an object of mass 3 kg from the surface of the earth and put it on a table of a height at 50 centimeter. Calculate the potential energy of the object, and the value of gravitational acceleration will be 10 meter per second square. So mass is given, that is 3 kg, and height is 50 centimeter. Then the potential energy will be mgh. And by multiplying these kinds of values, the m is given 3, g is 10, and the height is 50 centimeter, you have to convert it into the meter by dividing it by 100. So the potential energy will be 15 joule. The next example, that is example 7 on page number 154, spring constant is given of a spring, that is K is 6 into 10 to the power 3 Newton per meter, and the work done, you have to calculate the work done to stretch it by the 1 centimeter. So in this condition, x is given in the terms of centimeter, you have to convert it into the meter form by dividing it by the 100. So the formula will be half k x square, the value of x and k is given, then by calculating it, you will get the answer, that is 0.3 joule. So today we have discussed the work and the term energy. We have discussed the transformation of energy from one form to another. We discussed the value of work done in the different conditions, the maximum and minimum values of the work done. Then we discussed the mechanical energy, basically the two forms, that is kinetic and potential energy. In the next class we will discuss another form, that is the electrical energy, and then we will discuss the power. Thank you.